total number is 92. We started with the lowest element exists in this earth, which is hydrogen, and continue up to the heaviest one, which is uranium. And we said that some elements have what is called isotopes, and some of these isotopes are unstable, and we called these isotopes radioactive source or radioactive atoms or radioactive nucleus, or sometimes we call radioisotope. And we said that these radioisotopes or radioactive sources, the atoms cannot stay in this unstable conditions, and the atoms will try by itself, without any help from external, by itself, try to reach to the stable state. We call this process the nucleus decays. So the atom or nucleus decay means the nucleus try to reach to stability. And how the unstable or radioactive nucleus or atom do this, we say that the nucleus has 5 options. Maybe during emission, what is called alpha radiation, this is alpha decay, or beta minus decay, or positron or beta plus decay, electron capture decay. All these decay modes change the number of protons and neutrons inside the nucleus to reach to stability. And as a result of decay, the radioactive nucleus converts itself to other nucleus, another completely different atom, different element. And sometimes the daughters that result from this decay may, when it create in excited state. The arrangement of proton and the neutrons are not in good arrangement. So the nucleus will rearrange, redistribute this protons and the neutrons inside the nucleus, and we call this process, it make relaxation, it make de-excitation. It is an excited state and will go to the ground state. During this process, transfer from excited to ground, the nucleus emit gamma, or the nucleus will give its excited energy to one of the orbital electrons and make what is called internal conversion. This is the modes of decay. Then we continue with the device that produces radiation, which is called X-ray. This device accelerates electron inside it. Then this electron hits a heavy metal target. Then this electron will de-accelerate, reduce its velocity, meaning reduce in energy, and this reduction will appear as a result of X-ray. And we said that X-ray is electromagnetic waves, like what? Like gamma. We call the X-ray or gamma sometimes, we call them X-ray or gamma, we call sometimes photon. Say it emits photon. It emits, the nucleus, for example, emits photon, or we produce from X-ray photons. And finally, we studied the sources of neutrons. And we said that we have 3 man-made sources. An isotope called Californium-252, it emits neutrons through self-fission. It's a decay also, but through what is called self-fission or fission. You can say fission. And we have the other source, which is called alpha neutron source. We used alpha source that emits alpha radiation that hit and light element like beryllium, then make nuclear reaction, and as a result of this nuclear reaction, we have neutron. And the final source for neutron is neutron generators. And we have two types. deuterium, and they produce 2 million electron volt neutron. And tritium, which produce neutron with 14 million electron volt. Today, inshallah, we'll start with the calculations for this decay process. Okay. Let's start with the topic of today. Today we are going to speak about activity of the source, activity of the radiation source, activity of radioisotope, the same meaning. First, what is the meaning of activity? We must give a definition for this quantity. Activity is quantity, like what? Like, for example, mass. When I need to have, what is the mass of this thing? Activity is also quantity, like what? Like time. How long time you need to do this, for example? So you need quantity. Activity is our quantity to measure the radiation activity is the quantity to measure the rate of decay of radioisotopes. Yesterday, we gave a definition for radioactivity. Radioactivity, the process itself. It is a spontaneous decay of nuclear to more stable configuration via emission of radiation. This is the radioactivity. Unstable to stable through a mode of decay, and as a result, we have radiation. Now, activity now, the quantity. It is the number of decay, sometimes we call this disintegration, number of decay per second. How many atoms of my source, as I know, the source consists of what? Huge amount of atoms. The source consists of a huge amount of unstable atoms. Okay, how many atoms will decay in 1 second? So, if I have a source now, assume a source now, 100 atoms. 100 atoms. And after 1 second, after 1 second, I found 10 atoms decayed, and remaining 90. I started with 100. Now, after 1 second, I found 10 decayed, convert itself to stable, and emit radiation, and the remaining 90. How many atoms decayed during this 1 second? I told you 10. So the activity is 10 decay per second. So activity as a quantity, it is the number of atoms that decays per second, in each second. This is the definition of activity. This is the definition of activity. We need now, for this quantity, activity, we need unit. For example, mass, okay, it's a quantity. It's a quantity, unit, kilogram, gram, ton. Time is a quantity to measure something. Day, year, second, week. This is the unit. Now, for this quantity activity, number of decays per second, the unit is becquerel. The unit is becquerel. This is SI unit. This is the international standard unit. We have two systems of unit. One is called SI unit, which is international standard unit, we used in this unit, for example, for time we used the second. For distance we used the meter. For force we used the Newton. For mass we used the kilogram. But we have all the system, all the system used another unit. For example, for distance or for length, we can use centimeter, we can use meter, we can use inch, we can use feet. This is all, this is not international system. The system international for length, meter, for time, second, for mass, kilogram. Also for activity, becquerel. For activity, we used becquerel. So in SI unit, we used becquerel as a unit of activity. What is the meaning of becquerel? If I say the activity of a source, activity, now I speak about quantity now, activity equal 10 decays per second, I can say in the unit of becquerel, 10 becquerel. 1 becquerel, 1 decay per second. 2 becquerel, 2 decay per second. So the becquerel really is the word decay per second. 1 becquerel, 1 decay per second. 1 million becquerel, 1 million decay per second. So 1 becquerel meaning 1 decay per second. And this is our unit in SI system. So becquerel is the activity of a radioactive source which undergo 1 decay per second. This 1 becquerel. Okay, but still up to now, we use the old unit or traditional unit, old system, traditional unit, which is Curie. So this Curie is another unit to measure activity. How many decays per second also. How many decay per second. This is the unit which is used in traditional system. Curie. Okay. Curie, if I say I have a radioactive source with activity equal 1 Curie, this means that there are 37 billion, billion, not million, 37 billion atoms decay each second. This is 1 Curie. 37 billion atoms decay each second. If this amount happens in the source, I will say this activity, the source activity is 1 Curie. 1 Curie. Okay. So if I have a source with 2 Curie, meaning double of 37 billion decay per second. We put this is in scientific way or form, which is 3.7 10 to the power 10 decay per second. Decay per second. I told you the word decay per second meaning what? Becquerel. So I can say 1 Curie equal 37 billion decay per second or 37 billion becquerel. 37 billion becquerel. Let's now use the board to start this unit. So activity is a unit to measure how many atoms decay each second. number of atoms, radioactive atoms, decay each second. If I say, assume 100 decay per second, I can move this and say 100 becquerel. 100 becquerel meaning 100 decay per second. So the becquerel is related to this word, decay per second. How many decay per second? This is activity. This is SI unit. SI unit system. SI unit system. Now we have another unit which is Curie. CI, Curie. 1 Curie, this is the unit of activity. So mention number, how many atoms decay per second. If the number of atoms that decay per second is 3, 7, 0, 0, 0, 0, 0, 0, 0, 0, 0, it is 37 billion atoms decay per second. 37 billion atoms decay per second. This amount called becquerel. Curie, sorry. This amount called Curie. 1 Curie, 37 billion atoms decay per second. What is the relation between becquerel and Curie? I told you this is decay per second. 37 billion atom decay per second. Move decay per second and what becquerel. So 1 Curie equal 3.7 10 to the power 10 decay per second or becquerel. This is the relation between all unit, traditional unit, and the SI unit. 1 Curie equal this amount, 3.7 times 10 to the power 10 becquerel, or 3, 7, 1, 2, 3, 4, 5, 6, 7, 8, 9. Becquerel. Okay, now we must pay attention about the conversion between this unit and this unit, between Curie and becquerel. Why? In exam, and we will solve some problem for exam. They give you a problem to calculate about activity, and give you the problem, for example, in millicurie. In millicurie, and asking in the answer, in the option given, for example, in mega becquerel. So in problem itself, the unit millicurie and the answer given in mega becquerel. So you need to know how to convert easily between them. Really, many of our colleagues solve this problem easily, but just he reached to the conversion, now it's a problem. It is a problem for him. He solves and gives the correct answer. But in millicurie, now the answer must be in mega becquerel. How he can move, this is a problem for him. So now let's give some example how to change this unit, and in simple way, and we will make it in very slow method, but sure that you have the correct answer. Okay, I know some of you can convert it easy, but some of our colleagues, this is a big problem for him. Slow down conversion. Okay, so for you, if you can convert it easily by another way, okay, do it. But I will do now something that makes the situation easy for the person who has problem for conversion. Okay, let's Say, I have a source now with activity, assume 30 millicube. I need to convert to how many megabecquerels? As you see here, we use milli, mega, sometimes use microcurie. For example, 700 microcurie. How much it is? For example, gigabecquerel. So we have milli, micro, mega, giga, sometimes kilo. So we need first, we need to know what is the meaning of this milli, micro, mega, giga. We need to know this first. Okay. When I say micro, this is the mu of micro. Mu meaning micro. Mu, micro, this is the symbol. I can move this symbol and put 10 to minus 6. So micro is 10 to minus 6. Meaning 1 over million. 1 over million. 10 to minus 6 meaning 1 over million. 10 to minus 6. For example, I say I have, assume, I say I have a source with activity, assume, 5 microcurie. Curie is unit of activity. So this is activity of radiation source. 5 microcurie. What does this mean? I can write this by this way. This is 5, put 5. This micro, I can move it. Instead of this symbol, this letter, I can move it. And put instead of it, 10 to minus 6. And put Curie. This 5 microcurie, I can write in this way, or I can write in this way. In the number format or in the symbol format. Let's say. So micro is a symbol. You can remove and put instead of 10 to minus 6. Okay. Now, let's take this an example. I ask you 5 microcurie. How many becquerels? How many becquerels? This 5 microcurie. How many becquerels? Now, okay, I will say this is the 5. Don't have 5. I don't need micro because there is no micro here. There is no micro here. I don't need micro. Okay, move it and put number. 10 to minus 6. So 5 times 10 to minus 6. So 5, micro moving here 10 to minus 6. Now Curie is 3.7 10 to power 10 what becquerel. I know 1 Curie is 3.7 10 to power 10 becquerel. So 5 microcurie is 5 micro 10 to minus 6, Curie 3.7 10 to power 10. All this by multiplication. So we have.
Doctor, sorry, but you can't see the bottom.
Okay, sorry, huh? Is it clear now?
Thank you very much. Thank you.
Okay, let's maybe some of you didn't get it. I will start again. Okay. I told you micro mean 10 to minus 6. Like in this example, let's take I have an activity 5 microjoule asking you how many decade but in becquerel, activity in becquerel. This is traditional, this is SR. Now, this is like multiplication. 5 multiplied mu multiplied q. So 5 is number, we put 5. I have here micro, I don't need it. I don't need because I don't need here. Okay, so move it and roll it into -6. Now, curie multiply 3.7 you must now memorize this number. What? Becquerel. Now it's a multiplication only. It's a multiplication only. 5 times 7, 35. So 5 times 3, 15, and we have 3, which is 18. And now 1 decimal here. Okay, 10 to -6, 10 to the power 10. This is meaning 10 minus 6, 4. So it is 10 to the power 4. Becquerel. So now I convert this 5 microcurie. How much in becquerel? It is 18.5 10 to the power 4, which means 85000 becquerel, which is 185,000 decay per second. Becquerel meaning decay per second. Now this is equivalent to this, and now we convert easily. So this is the method. Okay, let's go to the milli. I can move milli and go 10 to -3. For example, I have 300 milli, this is millimeter. How much is meter? You say milli, move it. This is 300 times. Milli is 10 to -3 meter. We use it milli, 10 to -3, or sometimes it is, this is 0.001. So milli is 10 to -3 or 0.001 or 1/1000, all the same. Let's take an example. Assume we have 8 millicurie. What is the amount in becquerel? Same situation like that previous example. This is like multiplication. 8 is a number. Look at it as it is. Milli 10 to -3. Curie is 3.7 10 to power 10 watt becquerel. So now I converted 8 millicurie to this number of becquerel. Now 8 times 7 we have 5. This is 40. This is 2 9s and point 10 to power 7. 10 minus 3 is 7 becquerel. So we have this amount in activity in becquerel, which is equivalent to this amount, equal this amount there. But now this is in becquerel, this is in millicurie. In exam, you solve the problem until now, but you find in the answer this. So you need to convert. Okay, let's go further step. But we will take now all the symbol that we will use. I told you, micro is 10 to -6. Milli is 10 to -3. And kilo is 10 to power 3, not negative, like positive here. 1,000, this is meaning 1,000. And mega, this is kilo. This is mega. Mega or million. Mega or million. This is a small m, this is capital M, million. This are 10 to power 6. And we have giga. As you say in your computer, what is that? Memory. How many giga you have? Gigabyte. This is giga, which is 10 to power 9. Billion, million, kilo, milli, micro. 10 to power 6, 10 to power 3, 10 to power 3, 10 to power 6, 10 to power 9. So we need to know this prefix. This prefix we need to know. Now, let's if you have, for example, 6 millicube, you need to convert it to, now, how many megabecquerel? How many megabecquerel? I will say, this is 3 terms multiplied together. 6 times m, milli times cube. Okay, 6 milli 10 to minus 3. Cube 3.7 10 to power 10. Now convert from curie to becquerel. So it is 6 10 to minus 3 times 3.7 10 to power 10. This is now the amount in becquerel. Okay, I will keep it as it is. I will keep it as it is. 6 10 to minus 3 times 3.7 times 10 to power 10. And I will write here becquerel. Only I got here. But he asked it in megabecquerel, not becquerel. Megabecquerel. Okay, it's easy. I will multiply this by mega, million, and divide it by million. When you multiply a thing by any number by number and divide it by another by the same number, for example, this is a number, this say 10. If I multiply it by 5 and divide it by 5, it is 10. It is 10. If I multiply it by 6 and divide it by 6, it is 10. Same. So I do the same thing. I multiply it by million and divide it by million. But instead of say million, I say mega. Mega divided mega. Same thing. I didn't make anything. I didn't make anything. That's it. Now, I need a megabecquerel. I need a megabecquerel. You need this. You need in this unit, megabecquerel. Keep it as it is. Keep it as it is. Now, I will take this m and put here. Only. So I will write 6 10 to minus 3 times 3.7 10 to power 10, and I got mega here, but I will put number. Mega meaning 10 to power 6. Now megabecquerel. So I convert this now to megabecquerel. It's easy now to make calculation. So with the calculator, you will say this is 6 below. It will be up minus. With minus 9. This is now 10. So it is only 1. So it is 6 times 3.7 into 1, which is 10 megabecquerel. By calculators, you can say 6 times it is 2, and this is 18. This is 2, I think 2, right or not? 18, and this is yes. Now, and you have here point, and you have 10 here. This is megabecquerel by calculators only. Now we need only calculator to this. So our way is, if you need to convert from 1 to hours, okay, put the number as it is. Okay, now replace the M with the equivalent number. Curie, you must know this. So now you put in becquerel. Write it as it is, but what you need, mega, put mega, and divide it by mega. Keep this away, and you put this mega as a number here. Now, it is the conversion between millicurie and megabecquerel. Let's take another example. Assume I have 5 curie. How much? It is gigabecquerel. Gigabecquerel. Okay. Start from here. 5 number. Put it as it is. Curie, convert now. 3.7 10 to power 10 what? Becquerel. So 5 curie is 5 times 3.7 10 to power 10 becquerel. Becquerel meaning decay per second. Always remember this. This is the amount of atoms decay per second. Activity of this source 5 curie. This is the amount decay per second. Now I need to put giga, not only becquerel. I need to add giga. Okay, add here giga and divide giga. Take this gigabecquerel here alone. We need it. Now, 5 times 3.7 10 to power 10. Give this giga here, put here, and put that number, 10 to power 9. 10 to power 9. Finish it. It is, this is 5, 1, 8. 5, 1, 8. Gigabecquerel. Through calculators, you can get 185 gigabecquerel. So it's easy now to convert by this way. If you have another way, do it. But I told you, some of our colleagues have difficulties in conversion. This is where I suggest for you. So 5 curie is this amount of gigabecquerel. Now let's take an example another way. Assume I have now, let's say 8 megabecquerel. I need to convert to how many millicurie? The opposite now. The same way. This is 8 multiplied mega multiplied becquerel. Okay. I will
Excuse me, doctor.
Yeah. Yes.
If you allow me, just raise the camera a little bit, just to see the beginning of the.
Okay, my friend. Okay.
Yes.
Now it's clear now?
Yes.
8 megabecquerel. How much is millicurie? Same way. 8 number. Put it as it is. Mega. I don't need mega here. So move it and put the number instead of M as a symbol. Put number 10 to power 6. Mega million. Mega million. 10 to power 6. Now, becquerel. We know that 1 curie is 3.7 10 to power 10 becquerel. Now the reverse. Becquerel is 1 over 3.7 10 to power 10 curie. So becquerel is 1 over 3.7 10 to power 10 curie. Now, this amount converted to curie. I will rewrite it again. Only rewrite. 8 10 to power 6 divided 3.7 10 to power 10. What? Curie. 8 megabecquerel equal this in curie. Now, I don't need curie, I need millicurie. As we said before, I will write it 10 to the power 6, 3.7, 10 to the power 10. As you see, I didn't make any simplification. I can say this is with this is 4. No, don't do it. I will make it as a whole when I finish. So I take it as it is. Now I will add milli and divided milli. Multiplied by milli, divided by milli. Curie. I didn't make anything. The same. Now I need to take this away because this is the unit I need. And this m, I will get it here. But numbers. So I will say 8, 10 to the power 6, divided 3, 10 to the power 10. And I will multiply it here by m. It's 10 to minus 3. Millicube. Through calculators, you can calculate this. Now, this is 10 to the power 10 and this 3 minus 3, meaning now 10 to the power 7. And above it will be minus 7. So this will be 0.8 divided 3.7. 0.8 divided 3.7, how much millicube? You can get in calculator. So this is 0.8 divided 3.7 millicube. By calculator, you can get this number. As you see, if you follow this method, it will be easy to convert between becquerel to curie or curie to becquerel. This is the last one to finish. Assume I have this amount. It's 100 megabecquerel. What is the amount in microcurie? Microcurie. 100 is 100. Mega is 10 to the power 6. Becquerel is 1 over 3.7, 10 to the power 10 curie. But I need micro. Okay. I will rewrite it again. This is 100 meaning 10 to the power 2. 100 meaning 10 to the power 2. This is 100. 10 to the power 2 times 10 to the power 6 meaning 10 to the power 8. This is the numerator. Denominator now 3.7 10 to the power 10. Curie, but I don't need curie. I need micro multiplied by micro divided by micro. Take this away because I need microcurie. So it is 10 to the power 8, 3.7, 10 to the power 10. And now bring this micro here, but numbers. It is 10 to minus 6. Put it in its place as it's about. Don't say it's in the denominator. Above 10 to the power 6. No. As it is, put it the value. This is in denominator, not 10 to minus 6. Okay, now, and microcurie, this. Now, it's easy now. This is 10 to the power 10, 10 to minus 6. This is 10 to the power 4. Above, it is 10 to minus 4. And this is 8, so this is 10 to the power 4 divided 3.7 microcurie. By calculator, you can get this. This is about, I say, it's about 2.2, I say, calculate. So this I will take 10, and I will consider this is like 4, so 2.2 or 2.3, 10 to the power 3 microcurie. I say about. This is the value, how many megabecquerel with, how much is microcurie. This is the way to convert between this activity units. And it's important. It's important. As I told you, in exam, he gives you units in the problem itself and the answer in another unit. So take care about the conversion between them. Let's return back to the slides. This is the prefixes for conversion. Tira meaning 10 to power 12. 10 to power 12. Meaning 1 and you have 12 0 in front of it. Some of our colleagues thinking that this is 10 and 12 0. Not 10 and 12 0. No, it's 1 and 12 0. Okay? Giga, 10 to power 9 billion. Mega, 10 to power 6. Kilo, 10 to power 3. Milli, 10 to minus 3. Micro, 10 to minus 6. Nano, 10 to minus 9. But really, we speak about from micro up to giga. This is our unit, really. Not tera or nano or pico. This is very low activity. Now, let's take an example. 5 millicurie, how much in megabecquerel? As I told you, 5 number. Milli meaning 10 to minus 3. Curie 3.7 10 to the power 10 becquerel. Now I will add m and divide it by m. Okay, the m in denominator, this one, 10 to the power 6. Now it's numbers, and you can now use calculator, so you have this amount of megabecquerel. Okay, another example. If you have 100 megabecquerel, how many millicurie? The opposite now. The same thing, the same way. So we have this value in millicurie. Okay. Let's take an example. This came in exam before. This problem came in exam before. A radioactive source of 1,200,000 decays in 2 minutes. So during 2 minutes, the amount of atoms that decay is 1,200,000. What is the activity of this sample in becquerel and microcurie? I told you the activity from the definition, it is the number of decay per second. And here we have number of decays through 2 minutes. So we need to know what is the amount of decay per second. 2 minutes has 120 seconds. 1 minute, 60 seconds. So 2 minutes is 120 seconds. Now, I will divide this 1,200,000 divided by 2 times 60. This is number of seconds in 2 minutes. So it will be 10,000 decay per second. DBS, decay per second. I told you decay per second mean what? Becquerel. You can move this and put becquerel. So the activity in becquerel is 10,000 decay per second. And now he asked you to give this activity in microcurie. Okay, this 10,000 becquerel, I will take, as we said, as we did in the board, becquerel meaning what? Becquerel meaning 1 over 3.7 10 to the power 10 curie. Okay, I will write it here. Okay, so now 10,000, this is the 10,000. Becquerel meaning 1 over 3.7 10 to the power 10 curie. So it equal to 2.7 10 to minus 7 curie. Only move becquerel and put 1 over 3.7 10 to the power 10. By calculator, it is 2.7 10 to the power minus 7 curie. Okay. But I need in microcurie. As I told you, you can put micro and divide it by micro. Let's do this. As you see, take the same number, but I add micro and divide it by macro. I multiply by micro and divide it by macro. Okay. Keep micro above as it is, and this micro put 10 to minus 6. Now you have 0.27 microcurie. This was a problem came in exam. So it's depends on what? The concept of definition, the concept of activity itself, the definition, it is number of decay per second, and you have here in minutes. So you must convert it to be second. Now, how to convert between Becquerel and Curie? Okay, we know now how to do this in a simple way. Okay. Also we have another way to express activity. Another way, like what? If I have a sample now, I have a sample, for example, soil sample, contaminated with radioactive. Assume soil sample contaminated with radioactive. And I need to know what is the activity of this sample. If you bring me sample like this, big sample, I will give you a number. I say, for example, 1 million becquerel. In this sample, 1 million becquerel. If you give me small sample, same soil, but small sample, I will say, assume 1,000 becquerel. So the activity now depends on what? The amount of soil that you bring for me to calculate, to measure. So soil, some mass like this, 1 million. But sample of soil like this, 1,000. So to avoid the confusion between 1 million, because it's a big sample, and 1,000, because it's a small sample, to take this mass away, we will say, we need to say activity in a specific activity. What is the activity for 1 kilogram of this sample? What is the activity of 1 kilogram? So if you bring sample like this, or sample like this, or sample like this, I will calculate the activity and divide it by the mass. So I will say how many becquerel per kilogram. If you bring a sample like this, or like this, or like this, the same specific activity. So we used what is called a specific activity when we measure activity and relate it to a certain another quantity, like mass. How many becquerel in kilogram? Sometimes I have a sample, liquid, radioactive source. If you bring the radioactive source like this, 100 liter, I have a high activity. If you bring a small, let's say half liter, the amount of activity low. So it's dependent on the volume. I don't need this volume to take into account. I will say how many activity in cubic meter, for example, or in liter, for example. So a specific activity is activity related to another quantity. If it is mass, it will be becquerel per kilogram. If it is, for example, area like what? Assume this table, I spill some radioactive here. So this radioactive now, spill in this area. I will ask you, what is the activity in each centimeter square? So now it's a surface now. So activity for surface, it is how many activity in each centimeter square, in each meter square, in each feet square, in each yard square. So it's a unit of mass. So in case of I need to refer to a certain surface which has activity, I say what is the activity in square meter, square centimeter, square feet. So I need unit of area. Okay. If I refer to volume, as I told you, cubic meter. How many activity in cubic meter, or in liter, or in cubic centimeter? Okay. In length, sometimes I have a source which is long. It's a wire. Sometimes the sources, the radioactive source come in as a wire. So what is the activity in each meter? What is the activity in each centimeter? What is the activity in each feet, in each inch? So what is the activity in unit length? This is specific activity for length. For volume, activity in unit volume. For a surface, it's activity over unit of area. Mass, specific activity in mass, activity in unit mass. Now, for SI unit, I told you, the unit in SI system is becquerel for activity, meter for length, square meter for area, cubic meter for volume. For volume, cubic meter. For area, square meter. For length, meter. For mass, kilogram. So if in exam, and usually you find this in exam, usually, I think some of our colleagues who enter the exam and now going to ask for renewal, maybe remember some question like this, saying what is the specific activity for surface in SI unit? Surface in SI unit. Surface and the SI unit, surface meaning area. SI unit meaning becquerel per square meter. So I will give you option becquerel per square centimeter. Yes, this is specific activity for surface, but this is not SI. Centimeter square is not SI. Meter square is SI. So it is becquerel per centimeter, per square meter. Sometimes give it to you like this. Curie per meter square. No, it's a specific activity for surface, but not SI. Why? Because activity SI, not Curie. It is becquerel. So it must be becquerel per square meter. This is a common question. Usually you find this question in exam about the unit of a specific activity. A specific activity. So, what is the time now? Yes, okay. So now, we studied this morning the quantity which is called activity. It is the amount of atoms that decay per second. How many atoms decay per second? This is called activity. We have units, two different units. One is SI unit, one traditional or typical or old unit. SI, becquerel. Traditional, Curie. What is the relation between them? 1 Curie equal 3.7 10 to the power 10 becquerel. What is the meaning of becquerel? Decay per second. 1 becquerel, 1 decay per second. 2 becquerel, 2 decay per second. Okay. Now, we have another way to express activity, which is called specific activity. Like what? Like density. Density is a specific mass. Density is a specific mass. Why? Because it's a mass in cubic centimeter, or in cubic meter. You say the density of water, for example, is 1 gram per 1 cubic centimeter. So you get the mass in 1 unit of volume. Or density of water in SI unit, it is 1,000 kilogram now. This is the mass. 1,000 kilogram in cubic meter in SI unit now. So a specific activity is something like this. It is the activity per surface area meter square. Length meter. Volume cubic meter. Mass per kilogram. So now we finished from the definition of activity and how to converge between units. Now let's remember together what we said yesterday about the decay rate. Remember when I gave you an example of decay rate and I told you only we observe only this phenomena, radioactivity, and we put some remarks or notes about these observations. And one of the observations we said yesterday about half-life. And we give an example. For example, cobalt-60 as a radioactive source. We found that every 5 years, the amount of atoms I have decreased by half each 5 years, meaning half decayed, finished, and become stable, and still I have half still unstable and will decay later. And after another 5 years, this half will decay, half of them will decay and remaining half, and so on. And cesium, each 30 years, we lose half of the atoms and remaining half. And after another 30 years, half will decay and remaining half, and so on. Iridium-192, each 24 days, about 2 months and a half. If we started with this, after 74 days, half will decay, remaining half, waiting. And after 74 days, half decayed, and the half is remaining, and so on. Now we can say another definition of half-life. Instead of saying half-life, it is the required time for 1/2 of the initial number of radioactive atoms to disintegrate. Half of the initial number. What is the time required to disintegrate? I will say it is the required time for the activity of the radioactive source to decrease by half. Instead of number of atoms, I will now use another way. What is the time? What is the time required that the initial activity of source decreased by half? This is half-life. Take an example. Assume now I have a source of cobalt-60. What is the activity? Assume 1 curie. Assume, let's say 10 curie to be easy for calculation. 10 curie. So cobalt-60, I have now source, new now, in this moment. 10 curie. After 5 years, this 10 curie will be 5 curie. After another 5 years, it will be 2.5 curie. After another 5 years, it will be 1.25 curie. For cesium, I have now a source 100 curie cesium. Okay, started with 100. After 30 years, it will be 50 curie. After 30 years, it will be 25 curie. After 30 years, it will be 12.5 curie. So, another way to express the half-life, it is the time or required time for the activity of the radioactive source to decrease by half. Same thing. Instead of saying number of atoms decreased by half, I say the activity decreased by half. This is another way to express activity, and we will use this definition. What is the time required for the activity of source decreased by half? This is the definition of half-life, and we will use this because really we deal with radioactive source by this quantity, activity. What is the activity of your source? So I will ask you, what is the activity of the source that you have? We will say 1 millicurie of cobalt-60, 1 millicurie. So now I know after 5 years, this will be half millicurie. So half-life is the required time to decrease the activity by half. Okay. As you see here in this graph, the activity decreased through time in exponential way, not line way like this. As you see, not like line. It is exponential. What does this mean? What does this mean? Assume now I start with 100 theory. After one half-life, it will be 50. After another one half-life, it will be 25. After another one half-life, 12.5. After another one half-life, it will be 6 something, and it becomes 3 something, and it become 1 point something, and it become half, and it become quarter, and it become, you will not reach at all for 0. You cannot say I have a source with activity equal 0. Never, you can't. You can't, because you take half from half, half from half, half from half, half from, you will not reach to the 0. Yes, you will reach to very, very, very low activity after long time, but you will not reach to 0. If this is line, if this is line, you will cut this time and you'll say 0, because this is activity. This is y-axis is activity, and this is x-axis is time. If it is line like this, if it is line, you will cut this time at here, for example. You will say assume after 100 year, I will get activity 0. No. This is exponential. You cannot cut this axis. You must always have some activity in your source. Yes, very low, but it's not 0. It's not 0. So, now, if you have an old source, if you have very old source, okay, like for example, let's say iridium. What is the half-life of iridium? 74 days, 2.5 months. Okay, assume after 30 years, what will be the activity? It will be very, 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 very low, but I can't say 0. It's near 0, but not equal 0. Very low activity, because after 30 years, half of 100, assume 100 theory, it will be 50, then 25, then I will have going to 0.0000001 theory. Very low activity, but not 0. So this is why you can't deal with radioactive source, all the radioactive source as normal waste. No. Why? Because still you have radioactive in your source. So this cannot be dealt as normal waste. This is radioactive waste. It needs certain regulations. Here in Saudi Arabia, you must return back this source for the manufacturer. Or if the manufacturer is not exist now in market, you need to re-export it again. Because here in Saudi Arabia, we don't deal with radioactive waste. You bring it for yourself as a company, return back to the manufacturer. I'm not responsible for this waste because it costs so much to save this in safe condition. It costs you so much. So return these sources back. When you don't need to use it. Why? Because the activity does not reach to 0 at all. Still we have. Okay. Okay, let's take a break for 15 minutes and to continue with the calculation. Only 15 minutes, my friends.